So what fascinates me most is that very simple rules can give rise to very complex behaviors when it comes to the systems containing of multiple objects or particles. My name is Tomasz Smoleński. I'm a tenure-track assistant professor at the Department of Physics of the University of Basel, and I am a leader of Quantum Optoelectronics Research Group. So in my group, we are using optical spectroscopy to investigate the behavior of systems consisting of many electrons that are strongly interacting with each other. And this is very fascinating because even though we can understand the property of interaction between each pair of electrons, just because we have so many of them, their behavior is very complex and often unpredictable. For example, such electrons form a very unique phases of matter, like superconductors or electronic crystals. And in my lab, we investigate those phases by engineering and fabricating new quantum materials that we make out of van der Waals crystals. And these crystals consist of individual atomic layers that we can peel off from these crystals using an adhesive tape, and then we can combine them together to form new types of materials with otherwise inaccessible properties. And finally, we investigate electrons in those materials under extreme conditions, so at ultra-low temperatures down to millikelvins and at high magnetic fields up to 10 Tesla. So our current projects focus on electronic crystals in which the electrons, instead of forming a liquid, organize themselves into a lattice, or very exotic topological phases of matter which hosts exotic quasi-particles that have charges corresponding to a fraction of an elementary charge. What fascinates me is the fact that very simple rules can give rise to very complex behaviors when it comes to the systems containing of multiple particles that are strongly interacting with each other. And in this case, the complex behavior of the whole system can be very different from that of each individual particle alone. And this rule is very universal. It applies to all possible systems in nature, not only the electrons in our quantum materials, but also birds in the sky or snowflakes that you can observe in cold winter days. And in my opinion, this nicely illustrates the beauty and universality of nature. So this will be a very exciting period. We plan to quickly grow our research group, and to this end we are constantly seeking for new people to join us within the frame of SNI projects and also ERC starting grant. So please feel free to contact me in case you would like to join our adventure.